Hi, I'm Paul Brodie in the shop with Mitch. I'm not going to actually make anything today. I'm going to tell you a story about a project I had back in 2007. That's 15 years ago, and it was a Ropus steam bike replica I was asked to build. I had a phone call from Dick. He was a customer down in Indiana, and a friend of his had a steam bike, and he wanted a steam bike too. So he got me involved in that. I said yes, even though I had zero experience. He had a friend in San Diego named Tom, and Tom said that he knew how to make a steam engine motor. So the three of us combined to build a Ropus steam bike. And Dick asked me at one point early on, he says, how much is this going to cost? Not having any experience, I pulled a number out of my hat. $8,000, I said, making myself in the months to come a complete liar. So here we go. Here's the slideshow. Thanks for tuning in. Here's the motor I got from Tom. He sent me up some AutoCAD drawings, and I checked the sizes to see if it was compatible with what I was building, and it was. So I said, okay. He never consulted me, and then when I got the motor, it was much larger than I anticipated, larger than the drawings, maybe 25% bigger. So it still fit, but as you will find out, that was a problem later on. I got the motor from Tom, and the valve is off. So this is the valve. This is like inlet, and that's exhaust for the steam engine. So everything's looking good at this point. I don't have any photos of the early frame, how it got made, but this is the frame. And the boiler, this is the boiler tube. It's 8-inch OD. It's seamless tubing, 1/4 inch wall. And I've welded some plates on 1, 2, 3, and that's what holds the frame on. So the boiler is an integral part of the frame. This shows how the engine is situated off the boiler. Now I want you to notice that, see this rod here? That's the rod which drives the back wheel. So it's got a support here. This is a slider that runs along the lower rod and the upper rod. And this rod here mounts onto an eccentric, so it operates like a locomotive, a train. And then there's another eccentric down here. This is the eccentric that opens and closes the valves. This is the valving system on the steam engine. This is the top box. I don't know what you call it, the steam box or the whatever box, but this is a 3-inch hole saw, and it's punched a 3-inch hole in there because the exhaust is 3-inch, and you can see it right here. There is the exhaust. You could call it a chimney. Now it's held together with some masking tape here. What's going to happen is there's going to be a brass ring that you can, and a handle, so that you can rotate the chimney up like that. Because when the chimney is up, you get more of a draft for the fire that's happening down here in the firebox. So you got the firebox and the boiler and the top box. I can't remember the name of the top box. It needed a center stand, so I've bent some, looks like 1/4 inch or 3/8 mild steel, gonna weld it. And this goes on to the bottom. This is the rectangular box that surrounds the boiler, or this is the firebox on the bottom. There's the stand. This is the bottom view, and those are the brass foot pegs for your feet. This is the side shot, and the stand is now down, and you can see the firebox. It doesn't have a hole in the side yet, foot pegs there. And this is the top view. So the entrance to the firebox where the charcoal goes, or the wood, is going to be on this side right here. This is the gauge. It's the pressure gauge that goes on top. And Dick supplied this, and this is a brass, no, it's a bronze ring, I think. And I'm going to fit the gauge into the ring. So there it is, it's mounted in there. I did a little slot for the 1/2-inch National Pipe Tap thread and fitting there. And here it's on the bike. You can see here how the exhaust, or the chimney, is upturned now. That's for more draft coming through the motor. And that's a close-up of the gauge where it mounts on the frame. This is some spring steel, and that's used to mount the seat. So there's a little bit of a cushion. You can see the wooden hand grip here. And on the left side here, I was looking at this photo, and it's been so long that I looked at these photos that I couldn't remember what this was. And looking through later, I realized this is one of the two water pumps. This is the automatic water pump that runs off an eccentric off the back wheel. We'll show more of that. Here's the entrance way into the firebox. There's going to be a screen that fits on the floor to stop all the charcoal falling through. And there's going to be a brass door that fits on the end here that you open up to put in the charcoal. Here is the water pump. This is the automatic water pump, and this runs on the eccentric on the left side of the back wheel. Here is a sight gauge that goes onto the boiler on the right side of the bike. This shows the water level. This is a special piece of hardened glass. It came from somewhere. It's not plastic or anything, because this has to take an awful lot of pressure. It's the pressure of what's in the boiler. So this goes right into the boiler, those two pipe fittings there. This is the drawings I made up for the throttle valve. What the throttle valve does is to open up and allow steam from the boiler to go into the engine. These are all the pieces that go into the throttle valve, and that is the actual valve that sits in a seat. So when you pull on the lever, that opens up and the steam goes into the engine. That's the throttle valve when it's all assembled. This screws right onto a fitting which is welded onto the boiler. This is the water tank that goes on top of the bike, and I made it out of aluminum, TIG welded it, 3003. And you can see here, this is the sleeve that allows the exhaust pipe or the chimney, it can rotate. Here's the top of the, maybe call this the upper firebox, I don't know. That's the tube, and it exits out the back. There's the bike. It's in a mock-up state sitting on my bench. Get a better idea of what's going on. This is part of the manual water pump, and if you look really closely, you can tell that I've focused on the background. So I was not at my best that day, obviously. That's the part right there that you saw in the last photograph. So these are all the pieces that go into the manual water pump, because when you get on the bike, somehow you have to get water from the water tank into the boiler. So you pump it in manually. So there's a system of valves. So if you look here, can you see there's a ball bearing that goes inside? So that ball bearing has to be held in there. It's loose in there, but this is a piece of nickel silver brazing rod. Can you see that? That stops the ball from rolling out. So there's a few situations on this bike where a ball bearing is used as a one-way check valve. This is the pump when it's assembled. This needs to be spray painted here. There's a ruler for scale. And this is what it looks like when it's sitting on top of the water tank. It looks like I still have to put a couple screws in there. So when you fill up the tank with water, it's distilled water, maybe because some waters have a lot of minerals in them that affects the engine itself. I don't know. Always distilled water. That's what I was told. Here's the throttle valve. It's mounted. You can see how it comes out of the boiler, and it goes down into the inlet valve of the steam engine. This is the actual engine here. This is the exhaust valve, and that's going to feed up into the chimney. This is a bunch of the parts that are being sent out for nickel plating. This is part of the spoon brake here. This is an eccentric for the back wheel. And Dick found a lever that he liked for the throttle. So this is not the brake lever. This is the lever that operates the throttle valve. This piece here is the spoon brake. This is what presses down on the front tire when you need to stop. So if it's raining and you're going downhill, good luck. This is some of the wooden handles that I made. This is the water pump. This is off the chimney, and this is the cladding that's going to go around the boiler. So I think these are mahogany. This might be oak. This is going to get a stain so it matches the oak, matches the mahogany color better. And there's the door that goes into the firebox. So there's a hinge here. It's a 1/4 inch National Fine. It's got a bit of slop. When the fire gets going, you use a glove because this is brass. It's going to get quite hot, and you lift it up. There's the catch. You open it up, swing it open, you put in charcoal. There's the water tank. It's all painted now. Also, this has been painted as well. This is just a flat black. This is gloss. There's the frame, Imron gloss black in my oven there. So this is where the cladding starts to get put on. It was quite the process because each piece has to be fitted individually. You can see here how there's different stages. Everything has, anytime there's some kind of a fitting, you got to make a hole, and then there's the brass strips, the brass screws. This is the other side done. There's the entrance into the firebox. That's where the charcoal goes. So the cladding's on the sides. This is looking at the back. That's where the chimney bolts onto, and you can see the throttle valve. Okay, the exhaust valve off the steam engine, it's plumbed into the chimney now. See that copper tube coming down there or going up there? There's the handle, which allows you to rotate the chimney to either a downward position or an upward position. Inlet, exhaust. And that's just a shot of the bike coming together on the bench. This is all the cladding taken off. It's going to get stained now. And these are all the brass pieces that hold it on the edges, and those are the aluminum pieces that get bolted to inside sometimes when there's not enough support. So there was quite a few things going on there just in the cladding. Here's the throttle valve, and I made up this little, it's like a raised up arch, and I put on a cable stop there. All of you bicycle people will notice what this is. It's a tube off a Shimano V-brake. And so what happens is when you pull the lever on the handlebar, it lifts up this lever here. That lever goes that way, opens up the valve, and the steam from the boiler inside here goes down into the inlet of the engine. Up front, this is interesting. In my conversations, when I was talking with Dick, he wanted a steam whistle. So that's what this is. This plumbs right into the boiler, comes up, there's a lever that operates the valve, and you see here it's just a tube which is closed off on the end, mounted onto the wood. Can you see that little cutaway there? That is a steam whistle. Down here is a check valve. This is like a safety valve, and it was set for, I can't remember, let's say it was 215 pounds of pressure. Let's say you light the fire in the boiler, it's building up pressure, you walk away to have a coffee or something, and the pressure gets too high. This is the valve that blows off the extra pressure. It's a safety feature. This is the basic unit here. This is the right side of the boiler. See these two fittings here? That's where the sight glass is screwed into. So it's going to tell you your water level of the boiler here. And then this is the left side, and see the fitting there? That's where the blow-off valve goes. When you finish riding the bike and you don't want all that steam anymore, you open up the valve and all the pressure is blown off through that port. This is all the fittings that got used on the bike. These are all brass fittings. They all go somewhere, and so that's a lot of brass. Okay, we're working on the ends of the boiler plates now. So that 8-inch tube I talked about, that 8-inch seamless tube, 1/4 inch wall, this fits inside, and it's a good fit because it gets TIG welded all around the outside. I've got copper tubes that go in to make up the boiler. So I'm drilling holes here, And these holes are undersized 5/8 of an inch. And the reason you do them undersized is because now I've got a tapered reamer, and that's crucial here. I forget what the taper was, maybe 2 degrees, 1.5, I can't remember. And you have to go down with the reamer just enough. It's kind of critical that you only go down a certain amount. These are the copper tubes. They're 5/8 of an inch OD, maybe 1/16 inch wall, something like that. That was 15 years ago, so copper cost less then. And this is the roller. This is the crucial thing. And this roller is over 100 years old. And if you look closely, you see the rod that goes down the middle. It's on a taper. And if you look really closely, can you see there's a roller? There are 3 rollers inset, and they are spaced equally around. So what you do is you put this into the end of the tube after it's inserted into the boiler plate, and then there's a square on the end, and you turn the square. And because these rollers are at an angle, it draws the roller into the tube, and it swages the tube into the boiler plate inside. Because if you don't do this, then you have to silver solder every tube around, and that's really, really iffy for a seal. This worked very, very well. And that was over 100 years old. Beautiful little tool. Here's the boiler. This is all the tubes are in. They've all been swaged out. You can see all the fittings that are being welded on the outside. And I got the pressure gauge installed. This is not its final position. This is just for the pressure test. And I got 300 pounds of pressure in there. So how do you get 300 pounds of pressure? You do not use air. That's the most dangerous thing you can do, because if anything goes wrong, you have an explosion on your hands. So what I did, I heard about this, and it actually worked really well. I filled up the boiler all around the tubes on the other end, I believe, because that's just a plug. I filled it up with water, so it was basically right to the top. I put in the plug, and the plug had a grease fitting. Then I had a good grease gun, and I pumped it up, and you can get a surprising amount of pressure. Well, I got 300 pounds of pressure with a grease gun, and it's perfectly safe, because if there's any leaks, it just starts to leak water. That's all. There's no chance of an explosion. So this is the pressure testing. So that was a success. So you notice that everything is painted now. All the boiler is painted flat black. There's the exhaust from the engine going up into the chimney. We got more plumbing going on here in the back. And once the plumbing was all done, that's when the insulation went in. There was a special kind of insulation I was told to use, and it's about 1 inch thick, and it definitely has some substance to it. That's what keeps the boiler warm and the wooden cladding cool. Although you'll see later that, well, not quite like that. There we go. It's looking more like a complete bike. That's the blow-off valve for when you finish your ride. There's an eccentric here, and so when you start to use the steam bike, the steam engine, you manually pump water from the tank into the boiler, and then once you're riding, this is a system where there's a shut-off valve here, and there's also a valve here, and I can't remember exactly how it works. When you look at the sight glass on the right-hand side, if you see the water level is low, as you're riding, you open up the valve, and it fills up the boiler as much as you want, and then you switch off the valves. So that's part of the system of a steam bike. This is looking down from the top view. This is what the rider sees. So there's the hand pump, and that goes into the boiler, and there's going to be a check valve somewhere so that you can only pump out. What's in the boiler, all the steam, cannot come back. There's the sight valve. There's the throttle valve. So the bike looks like it's basically finished. So this is just some shots of it out in my backyard. I think it's looking like a pretty smart machine. Peter thinks so too, obviously. So there's a few shots of what the bike looks like. And then Dick decided that he wanted a valve in the chimney. So that wasn't talked about before. So the bike came apart somewhat. So this is the valve, this is the wooden handle. And so this is the valve that goes into the chimney so you can open or close the chimney. He thought that was a good idea. So we had the bike on the bench and we hooked up air and we pulled the throttle and oh, the motor ran and the wheel spun and it was great. So we thought, okay, well, let's fire this thing up. So we put water in the tank, we put charcoal, we lit a fire. Maybe 25 minutes later, we had some pressure. And so we pulled on the throttle valve and steam leaked out of the motor. There was steam coming out every part of that motor. So I guess Tom down in San Diego, he was not the expert that we were led to believe. So it got taken apart and it got sent off to someone else in the US. I think he was in Crested Butte or something like that. So he was the real expert. So he went over the whole motor. There were bores out of line. There was all sorts of problems. So a few months later, we got the engine back and we put in more water, more distilled water. We lit a fire in the bottom and we got it up to pressure. And so we actually did some testing. This is what happens when you're finished using the bike. You can see how you open the valve and you blow off all the steam, because there is quite a bit of pressure inside the boiler. So here's some evidence that we were riding the bike. You can see the mud there. So it was not great because when Tom made that motor and he made it oversized by 25%, he thought he was doing us a favor because a bigger motor is more power, right? Well, what happens is a larger motor uses up the steam at a faster rate. So what ended up happening, it was a mismatch. It was a mismatch between the size of the boiler and the size of the engine. And once you got it up to, I don't know, 180 pounds and you rode up and down the block, now you were down at 145 and you didn't really have a lot of power and you'd only been up and down the block. So not the best. You can see how hot the wood got and it burnt some of the siding. So that was unexpected, not good. Even though you can see all the insulation right there, this door got really, really hot. So I made up a template and I did make a piece of brass. I don't have a photo of that, but I did get to ride it. And when you ride a bike, because of the steam coming out the back, there's always a cloud behind you. That's what it looks like when you're on a steam bike. We hope you enjoyed that little sojourn back into the past and talking all about steam. You probably think I'm an expert. I don't consider myself a steam expert. So if you start asking me questions about steam, I probably cannot answer, but thanks for being along for the ride, hanging out in our shop. Mitch and I like coffee. If you buy us some coffees, we appreciate that very much. Give us a thumbs up if you enjoyed that. Subscribe. See you next time. Take care.